So then we have here average rate of change. So we have two definitions. The first one is average velocity, and we write it like VF. It is change of distance over change of time. Then we have another definition which is called instantaneous velocity, and we need to distinguish between these two definitions. So definition 272 said, let us S, which is st, be a function that gives the position of an object moving in a straight line. Then the instantaneous velocity at a time t is equal t naught is given by vt naught is equal limit of st naught plus delta t minus st naught over delta t, where delta t approach to 0, which is equal limit of delta s over delta t, where delta t approach to 0, whenever the limit exists. So the average velocity will be delta s over delta t. And if you take the limit of delta s over delta t when delta t approach to 0, that will be instantaneous velocity. يعني عندنا تعريفين. التعريف الأول average velocity اللي هي السرعة المتوسطة، التغير في المسافة على التغير في الزمن، delta s over delta t. عندنا تعريف ثاني اسمه instantaneous velocity اللي هي السرعة اللحظية. طيب إيش الفرق بين السرعة اللحظية وما بين السرعة المتوسطة؟ السرعة المتوسطة ناخذ دلتا اس over دلتا تي، بينما في السرعة اللحظية اللي هي instantaneous velocity ناخذ limit of دلتا اس over دلتا تي لما دلتا تي approach to 0. يعني السرعة instantaneous velocity عبارة عن limit of average velocity لما دلتا تي approach to 0. And let us see this example, which is the height s above ground of a ball dropped from the top of St. Louis Gateway Arch is given by St is equal minus 16t square plus 630, where s is measured in feet and t in seconds. A. Find the average velocity of the falling ball between the time the ball is released and the time it hits the ground. B. Find the instantaneous velocity of the falling ball at t is equal 3 seconds. So here we have a ball. It is dropped from this height, which is 630 feet, and hits the ground at some time. And the equation of the s, or for the distance, it is given by minus 16 t squared plus 630. We are asked to find the average velocity, so we need to find delta s over delta t. Then B, we ask to find the instantaneous velocity when t is equal 3 seconds. So let us see how can we do this example. So here we have a sketch of the question. It says that st represents the distance between the starting point to the end point, which is minus 16t squared plus 630. So at the top here we have the distance is 630 and the time is equal 0. But when the ball hit the ground, we know that the s is equal 0, but the time is missing. So first of all, let us find what is the time when the ball hit the ground. So when the ball hit the ground, that means st is equal to 0. So st is equal to 0. It is equal minus 16 t squared plus 630. So let us solve this one for t. So it will be 16 t squared is equal 630. So t squared will be equal 630 divided by 16. So from here t will be equal square root of 630 divided by 16, which is approximately it is equal 6.27 seconds. So t. So at this point we know that s is equal 0 and t is approximately 6.27. To find the average velocity, so v average it is equal delta s over delta t, where delta s, we know that s here it is equal to 0 and s here is equal 630. So it will be 0 minus 630 divided by, and we know that t here is equal 6.27. So 6.27 minus the starting one is 0. So this will give us minus 630 divided by 6.27. So the average velocity it is approximately equal minus 100.40 feet per second. Here the negative sign represents that the velocity is decreasing, or the direction of the velocity is to the ground. So now let us find part B to find here. So this one is part A, where we find the average velocity. To find the instantaneous velocity, so this is part A, sorry. To find the instantaneous velocity, we need to find the limit when of st naught plus delta t minus st naught over delta t when delta t approach to 0. So let us do this one. So for part A, we asked to find the instantaneous velocity at t is equal 3 seconds. So here we have t naught is equal 3 seconds, and we know that the definition or the rule for the instantaneous velocity is given by vt naught is equal limit of st naught plus delta t minus st naught over delta t when delta t approach to 0. So this will give us limit of s t naught, it is given by 3, so it will be 3 plus delta t minus s3 divided by delta t, and we take the limit when delta t approach to 0. So now we will go to our function. First we will replace any t by 3 plus delta t, so it will be minus 16 multiplied by 3 plus delta t all squared plus 630 minus s3. We will go to the function and we replace any t by 3, so this will give us minus 16 multiplied by 3 squared plus 630. So this is all will be divided by delta t. So now this will give us limit delta t approach to 0. Minus 16 multiplied by 3 plus delta t all squared, so this will give us minus 16 delta t squared minus 96 delta t plus 486 minus 486, so this will be all divided by delta t. And we see here we can cancel 486 with minus 486, and from here we can take delta t as a common factor. So let us complete it here. So this will give us, it is equal limit when delta t approach to 0, not limit of delta t. So this will be limit of, if we take from here delta t and from here delta t, we divide it by this one delta t. So this one will cancel with this one, and we will take one from here, we just left with one. So the final here will have minus 16 delta t minus 96, and this delta t will be out because we cancel it with one of this one and one more this one. So the left will be limit of minus 16 delta t minus 96 when delta t approach to 0. So here we have when delta t approach to 0. Now replacing delta t by 0, this will give us minus 16 multiplied by 0 minus 96, so this will give us, it is equal minus 96 feet per second square. So the instantaneous velocity will be equal minus 96 feet per second square. So the instantaneous velocity is given by minus 96 feet per second.